The new notation that we are going to learn about is called factorial. We use exclamation mark, and what it means is the product of n numbers. So 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is 120, and so on. So n factorial becomes n times n minus 1 times n minus 2 times n minus 3 all the way to 1. A few things to observe here is inside 3 factorial, you have 2 factorial. Inside 4 factorial, you have 3 factorial. Inside 5 factorial, you have 4 factorial. So in general, I can say n factorial is n times n minus 1. That just follows from the definition. Now there is something called a binomial coefficient. That's a symbol, NR. There are multiple ways of writing this. It can also be written as NCR, etc. But we're going to stick with NR notation. This means it's n factorial divided by r factorial times n minus r factorial. This is the definition. Let's look at some examples on how to use this. So 6, 2. So that's my n and that's my r. So I have 6 factorial, 2 factorial, 6 minus 2 factorial. That's 6 factorial, 2 factorial, 4 factorial. Now let's file them out. What is 6 factorial? It's 6 times, 5 times, 4 times, 3 times, 2 times, 1. 2 factorial is 2 times 1. 4 factorial is 4 times, 3 times, 2 times 1. All of this cancels out, and then 2 cancels out with 6 3 times to give 15. Next one, this is n, this is r. So this is 3 factorial, 0 factorial, 3 minus 0 factorial, 3 factorial, 0 factorial, 3 factorial. This cancels out completely, and this is 1. Why? Because we defined 0 factorial to be 1. There are some reasons why this is necessary, but mostly it's because in order to make things consistent. So we define 0 factorial to be 1. This is n, this is r. Now as the numbers get bigger, we sort of want to avoid doing this, filing it out. We want to use some nice property. For example, I can write 9 factorial as 9 times 8 times 7 times 6 factorial. Right? Because after this, it's just 6 times 5 times 4 times 3 times 2 times 1, which is nothing but 6 factorial, and this can be cancelled. So I have 9 times 8 times 7 over 3 times 2 times 1. This is 3, 4, and this is 12 times 7, so it's 84. And lastly, 4, 4 gives me 4 factorial, 4 factorial, 4 minus 4 factorial, 4 factorial, 4 factorial, 0 factorial, which is 1. So you notice that if this bottom one is 0, then you get 1. If they're both the same, then also you get 1. So we're going to combine the two ideas and present a binomial theorem in the next video.